Okay, so in this video we're going to look at a mortgages question. So we see here we have Peter purchases a new house, that's fine, at the age of 30. So it costs 370,000. He obtains a 30-year mortgage, fixed annual interest rate of 4.5, and then they tell us repayments are made at the end of each month. Calculated as monthly repayment correct to the nearest euro. So we're going to use the amortisation formula for this. It's a quicker solution. So you get P times I by 1 plus I to the power T all over 1 plus I to the power T minus 1. So P, the principal, is 370,000. Interest rate, we have a little bit of work to do. He's making monthly repayments, but we were given the annual rate. T will be 30 by 12. Which is 360. Okay, so we get 1.045 will equal 1 plus r to the power 12. So for the 12th rate, 1.045 minus 1 will give us 0.003674809. And now we sub into our formula, so we get 370,000 by your interest rate. Just be careful here that you only use I, not 1 plus I. It's an easy mistake to make. And then multiplied by 1 plus I. So that's 1.003674809 to the power of T, which is 360 all over 1 plus I to the power T. So to the power 360 minus 1. So all of that into our calculator. And all over 1.003674809 to the power 360 minus 1. So his monthly repayments are 1854.951473, and they say correct to the nearest euro. So that's 1855. Okay, so there's that question answered using the amortisation formula. So 15 marks. It's a much quicker and cleaner approach using amortisation formula, but we'll have a look at the series approach as well, because some questions will tell you to use that approach and not accept the amortisation formula as a solution. So it really just depends on the question. Majority of the time you can use amortisation formula, but sometimes it will come up where they will tell you using a geometric series. Okay, so I'll have a look at that. It'll be the same setup. So for us, we know because it's a repayment, it's going to be P is equal to F over. So P is the mortgage amount, 370,000. F, we call it A instead because we're solving. Our interest rate, we'll just borrow the workings from above. And then T we know is 360. So obviously you'd be doing your setup work here if we were starting this question from scratch. So we get 370,000 is going to equal A over. So we just need to establish maybe the first two terms of our series. And it'll go all the way up to 1.003674809 3674809 to the power of 360. So we use sum to n. So that's a times 1 minus r to the power of n all over 1 minus r. Sum to n is 370. The initial term a is a over 1.00. 3674809, or is 1 over the interest rate. And n we know is 360. Okay, so our goal here is to solve for n, so for a, sorry. So we get 370,000 equals a over the interest multiplied by 1 minus r to the power of n all over 1 minus r. Okay, so we'll cross multiply by the bottom, so that's 1 minus 1 over 1.003674809 divided by this square bracket. Will equal a over 1.003674809. So all of the left hand side into your calculator. So that's 370,000 multiplied by 1 minus 1 over 1.0036709 divided by 1 minus 1 over 1.003674809 to the power of 360. Close that bracket. We get 1848.159839 will equal to a over our interest. So then we cross multiply. So by 1.003674809, we get a equals 1854.951473, and we were asked for nearest euro, so that's 1855. If we look up above for amortization, we get the same answer there. So just in terms of the two processes, slightly different, and definitely setting up your geometric series is more complex and longer, and probably bigger potential risk of mistake in there. So if it's ever a choice between the two, always use the amortization formula. Okay, so that's us done for a mortgages question.